A basic introduction to propositional logic. Demonstration 4.1, arrow out. A conditional is symbolized by the arrow. It connects an antecedent and a consequent. It means if, then. If it says if, it's a sufficient condition, and this phrase will point to an antecedent. The phrase only if flips the order and makes it a necessary condition, and it points to the consequent. Arrow out uses a conditional and an antecedent so that you can get the consequent. It is a two-step rule. Problem 69. Both Emily and Tyrell are invited to the party, and if Emily was invited, I am too, since I'm her best friend, but Tyrell hates me, and if I go, he won't go, so either Emily and I go or Tyrell goes. Step 1, find the code words. In this case, you see that Emily is capitalized, Tyrell is capitalized, and the I is underlined. So those give you an indication that those are the main propositions that we're dealing with. E will stand for Emily goes to the party, T will stand for Tyrell goes to the party, I will stand for I go to the party. Step 2, symbolize the relationships. So the first statement says, both Emily and Tyrell are invited to the party. That's a clear and. So you just have E and T. Second statement, and if Emily was invited, I am too, since I'm her best friend. So this part about being the best friend is parentheses. It's not really relevant, but if Emily was invited, I am too. So this is a conditional, right? E, arrow, I. Next statement, but Tyrell hates me, and if I go, he won't go. So again, the fact that Tyrell hates me has nothing to do with this problem. So we're sticking to what is highlighted about going to the party. If I go, he won't go. So you'll have I, arrow, not T. So won't go indicates a negation. And then the fourth statement says, so either Emily and I go or Tyrell goes. The word so gives you a hint that this is a conclusion for the argument, because remember, a conclusion can appear in any part of the argument. It can be first, in the middle, or at the end. In this case, it's at the end, and you'll have either Emily and I go, so that's E and I, or Tyrell goes, or T. And you have to use groupers, because now we have more than one dyadic connector. So taking these pieces, we put them into our sequent. Remember, the premises come first, separated by commas, followed by the conclusion after the turnstile. So you have E and T, E arrow I arrow not T, and then the conclusion E and I or T. Next step, set up the proof. You take your premises and put them at the top, and then you put your conclusion at the bottom. Remember, once we pull the premises into the argument, we call them assumptions. So you have assumptions 1, 2, and 3. They were just given to us right now in the sequent. Right, so we have E and T, E arrow I arrow not T in our argument. Then we have at the bottom the conclusion, E and I or T. Now you have to think, how can I get to this conclusion and reverse engineer your way to the full proof? So notice that what's at the bottom, what's at the conclusion, we have a disjunction. We have E and I on one side, and then we have T on the other side. If you remember the or in rule, you can just or in if you have one of these pieces. So we're going to focus on getting the E and I first, because that's the order of this disjunction, right? It has E and I first. All right, so how do we get E and I? We say, okay, to get that, we put that on line 6 as our goal. We say, okay, we want to get E and I. Well, how do we get E and I? We need both of those pieces. Line 6 is a conjunction, right? It has two pieces. So we need those two pieces. We put them in there together. It's just a matter of how you want to group them, because and is commutative, right? You can do I and E or E and I, but it just, if it's the mold better, right, to say E and I, it matches, right? And then you go E first and I second. Okay, now we have all the pieces of our proof, and let's do the justifications. So for line 4, how did we get E? Well, we can just get that from line 1. We can do and out. Line 1 is a conjunction. We could just pull out the E, right? It's a one-step rule. Okay, line 5 is done a little bit differently. We look at the fact that line 2 has a conditional. It says, if you have E, you will get I. And do we have E? Yes, we do. On line 4, we just got that. So using those two pieces, we do arrow out. So to get the or on the last line, remember, you need the first disjunct, E and I. You have E on line 1, pull out of the conjunction, and you can get the I using the conditional on line 2. So this is what's called arrow out, right? Using an arrow and the first part of the arrow, which is the antecedent, then you can take out the arrow and just, you're left with the consequent. So using those, you can get the I on line 5, right? Lines 2 and 4. It's a two-step rule to do arrow out. Finally, or in is the final line. So we had on line 6, we combine lines 4 and 5 and get E and I, just using and in. And then line 7, we have the first part of our disjunct, which is E and I, and then we can just or in the T, if you remember how or in works from a previous lesson. Now, alternatively, you could actually get the disjunction using the T. Okay, here's the final answer. Now, the one on the left-hand side is the official one for this problem. However, there is an alternate way to do it that doesn't even use arrow out. You can actually do it without even using arrow out, because or is commutative. You could actually reverse the order and put E and I or T. Okay, so starting with the T on line 4, which you can just get from line 1 with and out, you can just say, well, T or E and I. However, because E and I or T follows the order that the words are given in the argument, the official way to do it is, it's a little bit nicer because it matches, but you could also do it alternatively by just saying, well, T or E and I. You can kind of show it in the opposite way. Or is commutative, so it kind of doesn't matter if you put the T first or the E and I first, as long as you legitimately get there. But again, it doesn't follow the wording of the problem as well.